Hello and welcome to Computer Tech and More. Today we're going to be taking a look at the Fractal Aspect14 computer fan. Well, let's get into the graphs and the details and the data. So first up, we're going to be taking a look at the case simulation test. This test simulates a computer case, and the way you should look at it is, what size computer case do you actually plan on buying and using inside your computer? That would be the data point that you want to focus in the key aspect on the most. So I took measurements at the 6, the 9, the 11, and the 14.5 inch marks. In all these data points, we are taking a look at an air cooler. That is the type of scenario that I envision for this type of test. So what I mean by that is a front-to-back airflow design with a standard type of air cooler. So one that inhales air in the same direction as the front of the case fans are blowing it. This does not take into account ultra-compact cases that tend to suck in air from the sides and then blow it out the top, or something effectively similar with regard to that. So now what does each data point actually represent? The 6-inch mark is that small form factor case I was just describing, where it sucks in air from the sides and blows it out the top, or something along those lines. The 6-inch mark is also representative of a short throw distance, meaning if you have case fans at the bottom of your case and you're blowing them up towards your GPU, that would be that short throw distance. The 9-inch mark is representative of your compact towers. Think something that can still hold an ATX or ATX motherboard in terms of the length, and so the GPU would be at that length as well, the length of the motherboard. And oh, I forgot to mention, these distances are from the front of the case, so the fans, to the rough position of the CPU socket. I want to make that perfectly clear, and I'm going to get into the explanation in a minute or so. And then we have the 11-inch mark. The 11-inch mark is representative of your standard mid-tower cases. Think like Meshify 2C, Corsair 550D, Corsair other 500 series from their Obsidian days, that Stormtrooper looking case from Corsair, something along those lines. And then you have the 14.5-inch mark. This is for big towers. Think something that can hold 340 millimeter class fans along the top or the bottom. Something like the Fractal Design Torrent would be sitting in that large case category. So you want to pay special attention to what actually size case you actually are going to be buying. And again, this is specific towards air coolers. Now, a little bit of science here. So we got the case fan. Let's pretend we have a heatsink right here over your CPU socket. So the fan works by accelerating air through it, and to accelerate the air, it has to pull a small vacuum in front of it. So naturally the air starts drawing in towards the fan. Well, if you have a high quality fan or fans in front of it to supply this fan with air, it now operates much more efficiently, because instead of having to pull air into it, air is being force fed into the fan, allowing overall cooler CPU temperatures. I actually plan on doing a scientific test of this in the near future to kind of hopefully prove my point. Otherwise I'm going to find myself incorrect, which would be a little bit embarrassing, but varying the steady state speed of front case fans. So I hope you're looking forward to that. I don't know when I'm going to produce it. And what you don't want are old style static pressure fans that tended to blow air off to the sides. This type of fan you don't want as a case fan, because it's not going to push air through your case. Mind, enough fans in the front of your case, even no matter how inefficient they are, will eventually provide enough airflow through your case, but you might as well get the most efficient possible, because then you're just literally better efficiency. Now, if you are going to be using an AIO at the front of your case, I know a lot of you will, you do still want high quality fans, because if your GPU is air cooled, you still need to supply that GPU with enough airflow. So even though the air is warmed from traveling through the AIO, enough airflow going through your case will still supply that GPU with enough clean air to keep temperatures in check. If it can't get enough air to it, so you're using lower quality, lower performing fans, it may not operate at peak efficiency, basically. So with regard to that, airflow pattern, as long as you're using these fans in a push configuration, so you've got the fan, then the radiator is actually going to straighten out the airflow, so it'll smooth it. So the fan design doesn't matter as much in that type of circumstance. However, if you're going to use these fans in a pull configuration, then the airflow matters significantly, because the pattern will match what we see in these graphs. And other than that, you want to make sure that you've got good exhaust for your case. I currently don't have an exhaust, but I'm also using the Fractal Design Torrent. The whole back is basically open mesh, or not even mesh, just open, so the air flows cleanly through it. If you have a more enclosed case, you do need a high quality fan to help get the air out of your case. And the airflow pattern of an exhaust fan doesn't matter as much as intakes. We're trying to get the air through the case, so I just want to have that little disclaimer. So what are we taking a look at here? Well, here's the Aspect, and then the other Fractal fan that I've taken a look at is the X2GP14, and I just wanted to have a little cross comparison between them because they're both available on the Fractal Design Torrent, just one in the RGB and one in the non-RGB versions. So you could actually take the data points and directly compare, or we can take a look at my noise normalized results. So we have my control fan here. It is base 3 parts A12X25 to 1 part A14. So blending a good 120 millimeter class fan with another good 140 millimeter class fan creates a good baseline for basically generically saying, hey, good, bad. So over it would be considered good to excellent. Under it could be considered, depending how close it is to the line, good to poor. So that's kind of baseline what we're taking a look at. So the Aspect14 and the X2GP14 actually line up fairly close to each other. It's fairly impressive, indicating that Fractal knew what they were doing when they selected these fans for the Fractal Design Torrent computer case. So that is always great to see, despite the fans having relatively different blade designs overall. So how do things look at 100% PWM fan signaling? First, a disclaimer, you should, in theory, never be running your case fans at 100% PWM fan signaling. It does indicate that something inside your case is terribly overheating, and you may need to look at your mounting for your CPU socket, or you're living in a very hot environment. Obviously, this is only for air-cooled systems. If you are using water-cooled, then that's a different scenario, and using 100% on those radiators is perfectly acceptable. So at 100% PWM fan signaling, we do see that the X2GP starts off significantly better than the Aspect. However, it loses performance pretty suddenly between the 11 and 14.5 inch mark, indicating that it has a semi-concentrated airflow, and then it just kind of dissipates into nothingness. While the Aspect lines up fairly closely with my control fan, just a little bit off the beaten path at that 14.5 inch mark. Overall, not a bad result. Now we're going to take a look at how these fans compare against other fans. And most of these are 140 millimeter class fans. Might as well compare apples to apples rather than comparing them to 120 millimeter class fans. So I know there's a lot of fans on here, but highlighted in blue is the Aspect14, operating bottom middle compared to the other fans. So certainly there are better fans out there. However, there are also worse fans out there. So it's not the end of the story. If you want to use this fan in your PC case, there's no need to actually just go out and buy a new one. You should find it perfectly acceptable. However, if you are starting from scratch, you might as well get a higher performing one to start off with. At 100% PWM fan signaling, it is effectively in the middle of the pack, which is not a bad place to be. I mean, well, I guess there are fewer fans underneath it than there are over top of it, so maybe it's towards the bottom of the pack. But it certainly isn't a poor performer. So again, reiterating my same point, if you already have this fan in your computer case, there's no need to replace it unless it's like making rattling sounds or not performing up to what you need it to do. So we have that going for it. And as for airspeed performance versus decibel rating, this graph was generated at the 9 inch mark, and the reason for that is many fans tend to drop off at the 9 inch mark. Mine is a little bit different for the 140s, but I wanted to maintain things consistently between the 120s and 140 millimeter class fans, and I needed an airspeed over 0.5 meter per second. Airspeeds underneath that, my current anemometer becomes a lot less consistent, which is why I would like to upgrade it. And the best way to help me with this channel, with growing it to acquire this better testing equipment, would be to join me on Patreon. I do have a vision for what I would like to achieve with this channel, with a little noise chamber, better anemometer, better microphone for doing my noise testing, all that kind of stuff. So if you like what I'm doing, please join me on Patreon. But what are we seeing on this graph? Well, we do see the X2GP and we see the Aspect here, as well as several other fans. If you're wondering about these fans that have these joggles off to the side, that is where I hit a harmonic frequency within the fan, or quote-unquote a peak. It is just where something inside the fan just vibrates and doesn't like that particular frequency running through it. So you want to avoid those RPMs, and they're generally associated with a PWM fan signal, so you just want to avoid that signal. We don't see any of those in the Aspect14 or the X2GP. The Aspect starts off fairly middle of the pack, but then loses significant ground and ends up being sort of towards the bottom of the pack in terms of its actual quality of performance. Certainly, I do think it's sufficient, but I don't see a reason to replace it unless it goes bad, basically. Same with the X2GP, actually. Next, we're taking a look at airspeed through my CPU air cooler. My cooler is the Noctua U12A. Yes, I know that is a 120mm class heatsink, but the air traveling through the heatsink section does not change with the size of the fan, so it's consistent to measure it. This allows me to compare 120s and 140mm class fans directly. So now that that explanation is out of the way, what are we taking a look at? First and foremost, on these graphs, upper left is going to be better performant fans. Bottom right is going to be worse performing fans. So the left graph here is RPM versus airspeed. This is fundamentally a blade efficiency graph. The control fan is the same 3 parts A12X25 to 1 part A14 in this test. Is a blade efficiency graph. So it's how effective is this particular blade design at shoving air through a restriction, i.e. the heatsink. So we can see my control fan sitting right here, and as we reach higher RPMs, air speeds, the 240mm class fans tend to have a better performance overall compared to the control fan. However, at lower RPMs and air speeds, the control fan tends to do a little bit better. On the right side here, we have noise versus airspeed. So now this is a noise efficiency graph. It is how quietly can this fan push a given airspeed. And this is where these two fans tend to fall apart. They're significantly noisier, about 5 decibels. So that's not twice as loud. It's like half again as loud. So like 1.5 or 100 or like 1.5. It's not percent. 1.5 louder, not 2 times louder. 1.5x louder. So that isn't a great place to be. Mine is, again, not terrible, depending on your perspective on it. But, yeah, and as a recall, every 10 decibels is a doubling in noise volume. Now, how do these fans compare against the other 140mm class fans? Well, a little note here. I did do a series of tests on my CPU air cooler, the Noctua U12A, for what airspeed traveling through it is associated with what wattage. And this is true for my CPU, the i7-11700K, and for the cooler, the U12A. So if you don't have either of those, you can't directly compare this data. But what you can do is use it as a relative standing point. So there's a wattage associated with an airspeed, and we know how quickly it pushes air through my heatsink, which means they would be in this order most likely with any type of radiator, heatsink, or AAO, whatever. So we know the positioning of the fan. So let's say you're starting off with the X2GP14 and you're using that on your air cooler or your radiator or whatever else. Well, it's moving 0.8 meters per second of air. Well, if you upgrade it to, let's say, the Mobius 140p, it's now going to be pushing substantially more air. So what does this mean? It means that your CPU, for the same noise level, will be able to run at a higher wattage if your CPU is unlocked. If your CPU is locked or has the clock speed limited, it's now going to be running at a lower temperature, or you can take that extra overhead and back off the PWM fan signal a little bit, and now your system is going to run quieter. That is how you can use this data. It is the relative position ranking of these fans. At 100% PWM fan signaling, both of them are towards the bottom of the pack. Mind 1.8, 1.7 meters per second of air isn't a bad result, but there are just other fans that produce a lot more airflow. So it's up to you to determine how you're going to use these fans and whether it provides sufficient airflow for your needs. In terms of airspeed through the cooler versus decibel rating, the aspect is towards the bottom of the graphs. It doesn't have the same sort of steep curve upward that many of the other fans do, so it is a bit flatter. But you see that it gains a lot of efficiency right here, so that's 20, 30, 40, 50, 60, 70% PWM fan signaling, but you're also dealing with a much louder noise level at that level where it finally gains efficiency. So it's up to you to determine if it's worth it to you. Overall, I would say it's shifted towards the bottom of the graph when compared to the other fans. And last, but certainly not least, is the CFM test. The CFM test is my least favorite, and allow me to explain why. So the CFM test, first, the control fan here is a little bit different than the other test. The control fan here is just the A14 because I have a different testing apparatus for 120s and 140mm class fans. So the reason I don't like the CFM test is because most reviewers are using it to say, hey, this fan is great at case airflow, but in reality, that isn't really what they're testing. So the CFM test that I'm referring to, so CFM is just a volumetric flow rate. You can convert meters per second by knowing the surface area of the object you want to measure into CFM, because you can see, like, the surface area of the tube, so pi r squared, and CFM is just cubic feet per minute. So let's put that in feet, and then the airspeed, let's put that in feet per minute, so feet cube per minute, so cubic feet per minute. Short math, okay? So the way it's done for many reviewers for case airflow just is incorrect. I mean, it's correct in a way, but doesn't give you the true idea of how it is in a case design. So you have a fan, it's the same size as the tube. You blow air down the tube, and if a fan has a tendency to blow air off to the sides, it has nowhere to expand it because this fan is the same size as the tube. So this means that the air is going to travel down the tube anyways. Mind, the air is still trying to go sideways, so it's just going to bounce off the walls and create a larger boundary layer. So a fan that tends to spear off to the sides will tend to have lower performance than one that has a nice concentrated airflow. But relatively compared to each other, they're going to look much closer in performance than they do on my case simulation test, which is why I think the case simulation test is actually the most important test here for case airflow. If you're watching reviewers who are only using this test and saying this fan good for case airflow because big number, they don't understand what they're talking about. They should be ignored with regard to this topic. Doing CPU thermal testing is very simple. You just run the fan through the CPU, you try to monitor the clock speed, wattage, whatever criteria you want, and that's very easy to determine. I just decided to use mine with Airspeed. So that part is very simple. Case airflow tests seem like they're much more complicated and harder for them to understand. I do have a background in computational fluid dynamics. I am an aerospace engineer, and that is the topic or the concentration of my master's degree. So yes, I'm a master's of aerospace engineering. CFM testing like this can be used, though, in a scientific sense. So you would generate a PQ curve, so pressure versus airspeed. So you'd have some pressure sensors, you'd need an anemometer to measure the airspeed, and a variable size slit to then measure how well this fan operates in different types of pressure scenarios. That is perfectly valid, but saying this fan good, this fan bad for case airflow because it has big number traveling through a tube is incorrect. So now that all of that is said, the red is my control fan, the A14, and right here we have the Aspect and the X2GP. Both of them underperforming my control fan very significantly in this test. Noise versus CFM, they are once again off the beaten path, the main control fan. However, the Aspect does appear much better in performance here. The X2GP is farther behind. How do they compare against other fans? Well, in noise normalized results, they are both towards the bottom of the graphs, indicating that they are very poor performers here. Let's move on. At 100% PWM fan signaling, while the X2GP14 is at the bottom of the graphs, while the Aspect14 is bottom middle. To be honest, they're both towards the bottom of the graphs. Now, how does CFM versus decibel rating actually look compared to each other? Well, it's not at the very bottom, but it is towards the bottom. So overall, again, in this test, they're not performing that great overall.
The Aspect14 is a feature fan in the Torrent PC case, the RGB version. Let's get right into the data and see if this fan is worth buying independent, or if you should even replace it in the Torrent PC case. Okay, now that we've done the basic analysis, let's do our open box experience. So it comes in a single pack, and there are also triple packs, I believe, in this very basic box. Mine got a little crushed along the way. It's got some product information as well as the RGB softwares that it does work with. So you should have no problems there. Tripwire technology, less turbulence. Alright, let's take a closer look at the fan itself. So the Fractal Aspect fan is of course an RGB fan, so you're going to have your RGB cables as well as your regular cable, which is plenty long. I was using an extender just because of where the cables come out from my fan testing. But the main aspect of this fan is this little trip zone in the front. I'm going to try to get it close. So it's got the thin fan blade right there at the front, and it trips right there. And that's purpose is to basically change the airflow to direct it back over the fan. So tripping it to turbulent or something like that, so that the air will travel along the fan blade rather than doing, well, something else. This is the only fan that I've, other than the other aspect, one that has a feature more like this. Most other fans will have like a grooves or something like that along the fan blades, but not this little, I'm going to call it like trip wire. So they are calling that like a micro turbulent, which is supposed to improve the blade efficiency. But pretty much other than that, this is a pretty much bog standard 140 millimeter fan. The frame design is not particularly well designed for radiators. It is fine for a case fan because you don't need that pressure application, so the fact that it's not squared off to create a nice seal on whatever's pressed against doesn't matter as much because it's just flowing through it. So that's fine. The struts in it are kind of arrow shaped. This big one for the cables is pretty flat and wide. So it's definitely more like a budget oriented fan. So it's up to you whether you find its value proposition adequate for its RGB level and I guess airflow performance, because RGB fans are more expensive for the same airflow quality as a non-RGB fan. The blade design is more reminiscent of a static pressure fan, meaning these fatter blades and not as curved in the front. So it's pretty in style now to have fan blades that look a lot like, well, the Noctua A12X25 or similar, while these fatter ones are more generally used for pressure fans. But the spacing between is pretty wide to allow plenty of air through it to be basically passed through for that airflow. So that might be Fractal's way of getting around these pressure-oriented fan blades, give them enough spacing so that it can be airflow and pressure, so that if a user really wanted to hook up a radiator to the bottom of their Torrent case, they could just kind of hook it up, use these fans in the meantime until they acquired better fans or something like that. But that's really not much home to write about. Let's go ahead and take a look at the RGB. Alright, now that we've taken a closer look at the fan blade design and done our basic analysis, before we jump into that value proposition, let's take a look at the RGB of this fan. So right now I have it on a fixed color, so I thought I could easily count the number of LED lights in it. It appears to have 6, which is kind of what I consider the budget category for a fan, where 6 doesn't get you great color blending, which I'm going to turn on now. But it's adequate and it creates a bright enough glow that it will look good in your case. But if you want to have specific sections with specific colors, if your software allows you to do that, it won't be able to do it. Or if you really like this rainbow cycling color, it won't have as good color blending as one with more lights in it. But I'd certainly call it adequate and a great in that more of a budget category for the number of lights. So really the performance will be whether you like the way it looks and its value proposition, which we'll get into next. the RGB appearance, I'm not an expert on RGB. I personally, my computer case is right here, don't really have much RGB in my case as it is, but this fan comes in the Torrent case. Its RGB appearance looks pretty good. If you're happy with the performance and you like the colors, well, it's certainly worth keeping. But if you don't, leaning towards probably replacing it with something that has more of the color or the number of lights, brightness that you prefer. But overall, I see nothing wrong with it. It looks pretty good. The colors, again, look pretty good. From the back, it's pretty basic. So it's nothing to write home about, but it's a fine fan. Alright, let's get into the value proposition.
And that brings us to the value proposition. The Aspect14 is a $40 fan, as I could find it on Amazon, so that is a very expensive fan for this level of performance. And as a note, once again, 120s and 140s can be directly compared against each other, except for CFM testing. Those, then, in that scenario, they cannot be directly compared. But in all other tests, the two types of fans can be directly compared with each other. So again, all value proposition calculations were based off of standard retail pricing, as I could find it on Amazon's website, meaning that there were no sale markers or anything like that off the fan. It was just whatever Amazon sold the fan as. So if you are shopping for fans, I do recommend that you recalculate value proposition at your time of purchase or check for sales, because the value proposition will change depending on the price of the fan. Even a couple dollars could significantly change the value proposition of any one of these fans. Now, who is value proposition specifically for? Well, if you're on an ultra tight budget and you're trying to squeeze every penny out of your build, then you want to pay special attention to these graphs. If you've got a little bit of extra spending money and you want an extra, so an extra, I'm referring to noise performance, you would look at the earlier graphs. Extra airspeed performance, you would look at the earlier graphs. RGB is an extra. That's for you to determine based on the fan's appearance. Or a certain physical appearance of the fan blade itself, that is an extra. So it's up to you to determine what your extra is and how best to weigh it versus how much the fan costs. So largely in the case simulation test, we're going to ignore the 100% pitot fan signaling, because in my opinion, you shouldn't be running your case fans at 100%. So the Aspect14 is underperforming compared to other fans. It's not in a terrible position. Well, actually it is a pretty terrible position, being well towards the bottom of the graph. But in terms of like comparatively, it's not too far off the average, but it is under the average. At the 11-inch mark, doesn't really improve. It is still off the beaten path, but relatively speaking, it's kind of in a better position, but realistically, it's not. So, in my opinion, it's not really worth considering as a case airflow fan, meaning to use it at the front of your case. Mind, if you are putting 3 of these fans at the front of your case, it's going to fill the volume with air, no matter how ineffective it actually is. So, just saying, that's what you could do with your Fractal case. But using them in that short throw distance all along the bottom of your case, perfectly valid, in my opinion. How about on CPU coolers? Well, once again, it is still underperforming, even at 100%, so it's not great for that. And how about in the CFM test? In the CFM test, it was underperforming. So where does that leave me with the Aspect14? Well, the problem with it here in value proposition is that the fan is too expensive for the performance that you get. The RGB on it I thought was fine, but it isn't worth the upcharge. Personally, I feel that this is like a $10, $12 fan, maybe $15 fan, $10 to $15 fan, that they then, just like the X2GP, that they then slapped RGB on and not tripled, almost tripled the price. It's not worth the $40 price tag. I would pay 20, maybe 25, under 30 for this fan, and then I would consider it a fairly good value. But anything over that, I would get something else. Let's move on to the next section.
Well, I want to thank all of you for watching my video on the Fractal Design Aspect14 RGB fan. I really appreciate all of you who watch it and made it this far. I've got a lot of other fan videos on my channel, and if you're interested in me checking out a specific fan, please leave it in the comment section down below and I'll go ahead and try to get my hands on it. Otherwise, subscribe for more content, check out my Patreon page, it's viewers like you that make all this possible, and I'll see you next time.
Alright, well that brings us to the end of the video. At the end of every video, I do like to show off my raw data. This data does belong to me. I worked long and hard to generate it for you. Every fan takes me about 1.5 hours to 1.5 to 2 hours to generate this level of data. As I implement more tests in the future, like adding a radiator, so if you got suggestions on radiators, like thick, ultra dense fin stacks on them, I certainly would like to acquire one for testing purposes. Better CFM testing, better everything testing. It's all coming in the future, hopefully. After, well, I get enough money. I don't really plan on making money off this channel, but I would certainly like it to be not negative. So if you can help support me on Patreon, I greatly appreciate it. Every penny would go into furthering my fan testing. But what was I saying? Oh, this data does belong to me. It takes me a while to do. If you would like to use it for your own personal use, i.e. copying it down to generate your own graphs for your own use on your own computer using your own Excel, you are more than welcome to do so. However, if you're going to use it in any sort of journal, written, video, whatever, anything that gets published into the public space, I do ask that you reference me and my channel, and you ask for my permission first. Most likely you're going to get it. If you got suggestions for fans for me to take a look at in the future, please leave in the comment sections down below. I do ask that the fan be available on Amazon, as that is the easiest way for me to acquire fans. If you got suggestions on how I can improve my videos, I do take constructive criticism very seriously. The key word there is constructive. If it's just going to rant and rave that I don't know what I'm talking about, well, I don't need that sort of negativity on my channel or the space. So, unfortunately, you'll probably just be ignored, because I actually do know what I'm talking about with this topic. My biggest limiting factor is just the size of my channel. So you are the ones who can help me grow if you like what I'm doing. If you don't like what I'm doing, well, I guess you're also the critics there too. I don't know what else to say. Thank you for joining me on this video. I hope to see you next time here on Computer Tech and More. Have a great day.